Hi, I'm Bobby Van Zetta, and I'm a team lead customer-facing data scientist at DataRobot. Today, I'm here to talk through some best practices for building best-in-class time series models, as well as doing proper model monitoring for those models and non-time series models. Also, we're just going to be talking through the changing times during COVID-19, how it's important to build models that are robust to that and adaptive to today's changing time, and of course, monitoring those models. So with that, our agenda for today is to talk through time series modeling and best practices for that, and then actually going in and monitoring, and then actually going into the execution of building some of those time series models with DataRobot. But many of these practices, of course, can be leveraged outside of DataRobot. And then going into DataRobot's model monitoring. Again, some best practices for model monitoring, which is not done enough when it comes to models, usually less than 5% of the time, but very important, especially today. So who we are. First off, I'm Bobby Van Zetta. I've been with DataRobot for 3 years. I've been in the machine learning and analytics space for over 10 years. And who is DataRobot? DataRobot is trusted enterprise AI. We've been around since 2012, and we have hundreds and thousands of customers across the globe and offices across the globe, from small to Fortune 50, Fortune 100 companies, and across many different industries. So from there, we've calculated, and we're dead set on actionable ROI-focused AI. And with that, we've estimated over 10 billion in savings and value creation to our customers. We are cloud native, so we run on AWS, but can install on your clouds, any of the clouds, as well as on-prem and bare metal. And we've received over a couple $100 million in funding and growing rapidly. And if we're not working with you today, I'd love to. So with that, let's get into some time series forecasting. Time series forecasting has applications across industries and across many different use cases. For example, predicting sales and accounts receivable for proper management of your resources, of when to spend and when to save, as well as IT outages. So predicting when a server is going to go down and getting ahead of that. Also, call center forecasting can be very important for properly managing and staffing, as well as many other use cases, such as demand forecasting. Demand forecasting we have seen to be a very valuable time series project use case. Many customers and many success stories like this. For example, with this success story, a very major, a very large retailer is receiving an estimated 300 million in value over the model we helped build. It was a couple people using DataRobot over a few months, and they were able to improve their already great accurate demand forecasting model by 9%, which ends up being around 300 million in terms of not understocking, overstocking, and proper management of resources. Now, also another use case is predictive maintenance. So predictive maintenance is something I've personally worked on, airlines, locomotives, many different use cases. It's really about predicting when something is going to fail and knowing why. So it can be figuring out the causes. It can be knowing when to fix something before it fails, potentially saving that asset, and even saving time if not over spending your resources in terms of predictive maintenance. Now, that's just to give an idea of some of the valuable use cases. Let's actually get into some of the execution and building of these time series models. Now, machine learning is really about training on the past to predict the future, and training on many different inputs over a potentially long period of time, even at a potentially granular level. Now, DataRobot and time series models should learn seasonal events and learn, interactions of different features of, can even learn from, say, the weather or macroeconomic variables for your business. But the point is, it is trained on the past. And with that, we are in a very, very different time. And COVID-19 and the pandemic, something we really haven't seen for over 100 years. So not many corporations have data going back over 100 years. And with that, there are certain events you can and can't predict with your business. And, your businesses do have spikes and drops. So hopefully we can help teach you today some methods to predict those. So some of these, in this chart you're looking at here, the orange is actual and the blue is predicted. So on the left side, you can see we're catching our spike in sales. This is predicting sales over time. And then, throughout the graph, we're doing a good job. But here in the middle, we're clearly over predicting. We're not catching that down. Did our business close? Was there some catastrophic event? What happened here? Could it have been predicted? So some of these events, you can potentially predict ahead of time. So let's say you're, a retail company, during Christmas and Black Friday, you might see a massive spike in sales. And that's something you should train on and learn from. Or let's say you're Super Bowl on doing ads, that can be spikes there. So really trying to learn on those. And also another thing is proxies. So this is where it can potentially help with COVID-19. So does your business have any proxies for what's happening today? Some companies have benefited, such as Lysol and others, and Zoom. But there's a majority of companies are not, right? It's negatively impacting them. Are you seeing similar trends as something that maybe has happened to your business in the past? There's a lot of other crises, unfortunately, that's happened in the past. Maybe you can learn from them. Point is, it depends. Depends on your business. Talk to your subject matter experts. Pull that data. Potentially learn from it. So now moving kind of high level into more of the granular feature building for your models. We're looking at a feature of price. This could be an input, an input product into what you're building, and this is the price of that product. So with that, the top graph, we're just plotting the price over time. This is the input feature. You can see there's a massive increase in the cost of this product and the price of this product. And if your model has a correlation between the input cost and how much the cost to your business, it's going to start predicting higher, which may be okay, may not be okay. But if you model and input the percent change in price, you can see the bottom graph for the exact same feature is a little bit more stable. There's a shock in the middle, but really, once it becomes a new normal, maybe that's what you should be modeling. Point is, I would say try both, see what works, talk to your business, and potentially try many other features, which we'll show today, beyond percent change. It could be standard deviations or differences, or rolling means. So beyond actually, training and building these best-in-class time series models, you need to be monitoring your models as well. So with DataRobot, which we'll be showing later, each row here is a different deployed model. You should be tracking the service health of the model, the drift, the accuracy of the model. One I really want to touch on today is drift. So how are the inputs to the model changing that you originally trained the model on? Important to track. Well, of course, the accuracy of the model in real life. So this is the drift. What has changed? What feature has changed? Is it price? Is it something else? How much has it changed? How important is it to your model? Is it a very important feature? Is it barely important? So getting that can be an early warning sign. So to see if your model is potentially degrading before you actually, before it actually shows up in actuals, which you may not get back for some time. So what do? You should have an action plan. So what do you do if your model does start to fail? If you do get these early warning signs, do you go to a previous model? Do you go to a challenger model? Do you retrain your current model? Do you stop using it entirely and move back to business rules? Should have those plans ready. So if you do start to see some degradation. And really having that for all your models is really important. A lot of companies are seeing degradation in their models. So really having that action plan and that proper monitoring is especially important right now. So before I get into some execution building of these time series models and monitoring them, I just want to give an idea of our platform. So our platform is really built for a number of personas, from excited business analysts and data engineers to IT and business makers or business decision makers, as well as of course hardcore data scientists. So a bunch of different personas. And what we do, we've automated the machine building pipeline and the monitoring and use of those models. So from the data preparation to the feature engineering, to building the models, to monitoring and deploying those models, as well as building applications automatically on top of those and watching the entire pipeline from a use case tracker. So we have that end-to-end and automated. We have this DataRobot can run on your cloud, on our cloud, turnkey solution, or as well as your bare metal hardware hybrid. So now that we give a background of DataRobot and what we do, let's jump into building a time series model and leveraging some of those best practices. So from there, I'm going to first go into the problem we'll be looking to solve today, and that's predicting sales on a daily basis. So this is my data set. My target is sales. So we're actually going to be doing this not just overall, but for my different stores. I have stores in Louisville and Baltimore. I'm predicting sales on a daily basis. So I have a lot of different input features here, and every row is a different day and a different set of sales. And as well, I have a bunch of input features. So I have the store size, the number of employees, returns percent that happened that day, the number of customers that came through my store that day. Watching the change in that can be predictive, the percent on sales, as well as some things I know into the future. So not just things that are happening that day, but what marketing events I know I'll be running, or is it near Christmas, or is it near Black Friday? Again, those proxy events or those calendar of events can be very helpful for predictive models. And we even have some other macroeconomic variables such as GDP and change in that. So really, with DataRobot and models in general, use numerics and categoricals and any and all of information that might be predictive to your model. And with DataRobot, can also bring location and images into your model as well. So with that, let's bring this into DataRobot. So DataRobot, a couple ways to bring in data, but we're just going to drag and drop today. Could bring in data, use a data source or others. So I'm just going to drag and drop that into DataRobot. And now DataRobot is doing what any good data scientist would do. That's doing some exploratory data analysis. It's learning about everything we just went over in terms of my input features and, potentially, learning about different statistics of, the mean, median, and standard deviations, missing values, things of that nature. And once DataRobot has done that, what we can do is start to build best-in-class models. So with DataRobot, all we really need to tell DataRobot is what we're looking to predict. So now DataRobot has looked through my data, and we're using about 10,000 rows of data here. Can use much less or much more. So what would you like to predict? If you remember, we're looking to predict sales. So you can type that in. Now with DataRobot, how easy it can be, you can just press the big shiny start button. We're off to the races. But before that, we're going to set a few things up. So first off, I want to let DataRobot know that I am trying to do time series modeling. So I'm going to set up time-aware modeling, click on my date feature, and select time series modeling. From here, I could just predict sales overall, but I'm looking to predict sales by store. So I'm going to let DataRobot know that. And now we'll be predicting sales on a daily level by store. From there, I'm going to go down to what DataRobot has looked at. It calculated all these statistics, the mean, standard deviation, missing, for all my different features. It also automatically identified potentially what's a numeric and what's a categorical, what's a text feature. And DataRobot will be handling that in our data pipelines we'll get into later differently. Could bring in images or location variables as well. And from here, we can also just look at our data and understand it. But what we want to do is also let DataRobot what we know in advance or not. So DataRobot will be using all the information, whether we know it in advance or not, just be using it differently. But we're going to let DataRobot know that we know the marketing events that we'll be running, if it's near Christmas or not, Black Friday, holiday, destination event, as well as promotional percents. So we're going to then let DataRobot, we know these features in advance. DataRobot will use them appropriately. Now, we also should let DataRobot know about building those features we were talking about before, percent changes and rolling means. What DataRobot defaulted to was looking back 35 days. So it'll create all these relevant features. What was my sales 35 days ago? What was the difference from 35 days ago? And other potentially relevant statistics. I'll just leave that default. Also, we want to let DataRobot know our business case. How far are we looking to predict in the future? For my business, if we could predict 1 to 7 days and properly staff and have inventory, that would be hugely valuable in business. So I'm going to leave this 1 to 7 days. Now, what's also important for time series modeling is how you set up what we call your partitions or doing back tests. What you want to do is train on the past and predict on the future. So we'll be training on about 1.5 years worth of data and then validating, so we're freezing the model and then validating and using that model, simulated over 67 days. And this is important to do because you will, retrain your model every so often, might be every month or two, and you want to see how well that model does for 30 days, 60 days in production. So we're simulating that, training on the past, predicting on the future 3 times over. And of course, you can do more than that. Now, one other thing I want to show is we've built in these, events that are coming up, such as Black Friday and others, through our input features. Also with DataRobot, you can just drop in a CSV that outlines, you can put your birthday in here, but really anything that's relevant to your business, such as Black Friday or Super Bowl. And it's important to be able, with DataRobot or not, build in those potentially proxy features or features and events that are upcoming and highly impactful to your business. Okay, so with that, we're ready to kick off DataRobot. Now, I'd normally let this run and go through this. This only takes a moment to run, but time is tight. I want to get to some model monitoring as well, so I'm going to move to a completed project of the exact same data. So moving over here, this is what DataRobot is doing currently. It's generating, and here it has generated many features. So if you remember, we started like 10, 15 features. Now we're looking at about 300 that DataRobot generated. It's doing this in a smart way. So it's looking at what is impactful to predicting your target and building out, sales is very impactful of sales. So what is the 7-day median, mean, the difference in those, number of employees. So all these lagged variables, what happened in the past, building out these features. This can be very impactful, and how you build those out is important. And DataRobot's doing it in a smart way, as you could do yourself. Now, with that, let's search through and show, some of these. We're looking at the standard deviation, the difference in the standard deviation, looking at the changes in sales can be very, very predictive, especially during, these really changing times with COVID-19. So that's the first step DataRobot took. And the next step is it built out many data pipelines, what we call blueprints. So I'll show one of those blueprints right now. I'm going to click on it. This is the blueprint we're looking at. This is eventually fitting an extreme gradient boosted tree and an algorithm for machine learning. And before that, it's taking your text variables, splitting those out from the categoricals, doing some encoding of your categoricals and numerics, doing a missing value imputation, and other methods. So it's really important to mix the best in practices data pre-processing steps with algorithms and trying many different combinations of those. And that's what DataRobot automates for you. So this is just one blueprint of many that DataRobot generated to try out for your data set and then train a model on that blueprint or data pipeline. Now, DataRobot created many of these. It created an extreme gradient boosted tree with different data pre-processing steps, a few different extreme gradient boosted trees, as well as ridge regressors and autoregressive models. And this is our leaderboard. So we're looking at all of these different now trained models on these different data pipelines that were developed by DataRobot. And we're looking at the out of sample accuracy. So the symmetric mean absolute percentage error. And this is the rough percentage error we're getting with our model. And it's sorted by that. So as we go down, it's getting higher and higher. And you can see, even just with the same algorithm, extreme gradient boosted tree, trying different data pre-processing steps is going to significantly change the out of sample error. And trying some other methods, you can see here we're in the 30s, the percentage, but if we move to the top of our leaderboard, all these competing data pipelines, now we're looking at 12%. And these are our different folds of our data, different periods. So it's a pretty stable model, low error rate. So this is great. So let's dig into it more. Now let's look at the accuracy over time. So we have the high level statistics, but now we actually want to look at some plots. A similar plot we were looking at before in terms of the orange is actual, blue is predicted. And we're looking at our store for Baltimore. So you can see here it's catching the spike appropriately. That's great. It's catching this massive drop. That's great. Very, pretty accurate model. Now, it could do a little bit better here, a little bit better here. Maybe we're missing a certain event. Maybe we're missing some input features that are predictive of that time frame. So that's where you can help go into your model and understand that. But overall, our model is looking good. It's catching this downward slope, potentially due to COVID, and things are looking good. So let's now move to forecasting accuracy. This plot shows how accurate we are predicting out into the future. So how accurate we are predicting 1 day out all the way to 7 days out on average. Anywhere from 13 to 15% predicting 1 day out, anywhere from 15 to 16%, not a horrible decrease in accuracy. And then this will depend on your business. So you find that happy medium of what the error rate you're willing to accept and how important is it in your business, how far you want to predict out, be it days, weeks, months, years, etc. So from there, let's go to understanding our model a little bit more and how it's thinking. So now we see this as accurate model. We want to potentially deploy, but now we need to understand how it's thinking and really selling this to the executives. So here, these are stack ranking the most important features. So we have sales at the top. It's the most predictive feature, and we've generated 39 features for that. Day of week, followed by day of week, marketing event. All these make sense, right? Sales is predictive sales. Day of week is important. The marketing events we're running are important. So this is great to see. It makes sense to me. And it should make sense to your business. And then going down, GDP, change in GDP, not that effective, not that important to the model. And some of these features you could potentially move, and potentially you could add more features if you have more information about your sales or more information about your marketing events. So again, that's just stack ranking the most predictive and important features to the specific model. But let's go into understanding the exact relationship of some of those features. So I'm going to click on day of week. And 0 is Monday, and then 1 is Tuesday, so on and so forth. So we see here the predictive relationship, and this is doing a partial dependence, is the 5. So this is Saturday. Saturday is the most, we have the highest predictive relationship of the week, as well as Sunday and Friday. So this makes sense. So you can start to click through and understand and trust your model. Now, from there, let's go to actually deploy our model. So now we understand it, we trust it, it looks good over time. So now we're going to deploy our model. While this can take some time with non-DataRobot approaches, DataRobot really makes it easy to deploy. One-click deployment, so I'm going to click deploy model. And here it gives me a few options in terms of, do I want to track data drift? Do I want to require actuals as they come in later? So on and so forth. So I do want to track data drift, which we'll be talking about momentarily. Now we'll create my deployment. There could be a model review process that DataRobot does, or you have one internally. And then from there, it goes to deploy the model, which DataRobot, it creates an API, which can easily be called from anywhere. And we have a few other deployment options. We can deploy onto Hadoop. We can export the model outside of DataRobot, put it into your environment, so on and so forth. But from there, let's actually move to a deployment and do some monitoring, which is as equally as important. And again, only 5% of models are properly monitored. So now I'm going to move to my deployments. I'm actually going to move to a deployment account, which is a lot more interesting deployments here. So from here, this is my dashboard, a single pane of glass for all of my deployed models. Now with DataRobot, these can be data custom models, so they can be containerized by DataRobot and deployed and monitored by DataRobot. So each row is a different model, and we have our high-level dashboard, and there's service health, drift, and accuracy, which we'll get into, and be tracking that in real time, which is really important, and having that dashboard. But we're going to move to a different use case. We're going to move to predicting loan default. So these are where you might not get your actuals back for years or decades for some of these loans. So it's definitely important to track data drift. So let's click in and understand this actively deployed loan default model. So the overview, we have all of our meta or governance data, which is important. So, who deployed this model, when they deployed it, who approved it, how critical is this model, what type of model is Python, scikit-learn, not even a DataRobot model. And this is important to track over time, doing your due diligence. Now, moving on, let's look at the service health. The service health, we can see, how often this model is being used, who it's being used by, what is the response time, do you need sub-millisecond response time? Is it okay if it takes a little bit longer? Making sure overall the model is being used and used properly without enough errors. And you can see here there's generally a lot of use and then some error rates, which we purposely put down, something to look into. So this is one important statistic. But what I want to focus on is data drift. So again, with our loan default, we may not get our actuals back and understand the accuracy of our model for some time. So it's important to track the data drift. Data drift is, how is the data now that I'm scoring on and using this model different than the data the model was trained on? So on this plot, on the y-axis, we have how the drift of those input features. On the x-axis, we have how important that is. So remember the feature importance from before. How important is that feature? So one of our most important features to this model is the interest rate, which makes sense for loan default. And now we double clicked on it. So all of these are in the green because they all have low drift, which is great. But we're going to click on this, and this is our most important feature, interest rate. On the right side, we have our training and scoring. So the dark blue is what the values our model was trained on, and the light blue are what our model is seeing now in development and in deployment. And you can see here we're getting more, we've seen an increase in lower interest rate loans. And we've seen a decrease in higher interest rate loans. So that's interesting. And again, these can be an early warning sign. So if interest rates started drifting significantly, this moves up for a DataRobot in this top right section as a yellow or red, that could be that could be a good early warning sign of, hey, maybe it's time to retrain or use a backup model or use a challenger model. So from there, let's move over to accuracy. And this is a binary classification problem. So it's predicting default, not default. One of the statistics for that is AUC. AUC is between 0 and 1. 0 is not a useful model at all, and 1 is a perfectly accurate model. So we were predicting and expecting around a 6-7 AUC, and we're seeing that. We're seeing a 6-7 AUC over time, and we can change our time window up here at the top. But there's a sudden drop off, right? That's worrisome. We definitely want to look in the model. So if there's any model drift, we could go back in time and see if there was drift and maybe what's potentially causing that. Is what else is going on? Is it just making less predictions, different types of predictions? But either way, our actuals, are coming back. This could be from years ago, and we're watching it. So you do want to track both the data drift and the accuracy of your models over time. Also, you can set up your own business rules. So we allow, with DataRobot at least, there could be other business rules that you're trying to track beyond the data drift of, how outlierish is the prediction than we normally expect. Is someone coming with an interest rate or a FICO score that's not even possible, right, in terms of fraud or something. So tracking those business rules over time can also be important and can be done here. One other thing you can do is deploy multiple models. So you're only using your one, what we call a champion model, and that's making these default predictions. But you could have 3 or 4 in the background that are making the same predictions but not being used, and those accuracies can be tracked over time. With DataRobot, you can see that being done here. So how are all these challenger models competing against my champion model over time? And this can be a good practice. If your champion model does start to fail, you could start to use one of these as a backup model. Hey, this other model's been working great. Let's back up to that, or move to a previous model or some other approach. Now, I don't necessarily want to be watching this real-time monitoring all day, so definitely good to set up rules. So I'm going to move to monitoring, and you can see here, if a certain feature drifts too much or a certain important feature drifts too much, send me an automated email alert, or send a group of people an automated email alert. Or you can set up other rules to, so you don't have to be watching in real time. So it's important to have these automated alerts set up. So then, and then also having, of course, your action plan on what to do next if anything does start to fail. So hopefully you found this valuable in terms of some best practices for building time series models, especially during changing times, building those models and then properly monitoring those models. Now, if you have any questions for me or DataRobot, I will bring up the contact information now. So DataRobot, you can go to datarobot.com or reach out to DataRobot, or of course reach out to myself. Hopefully you found that session valuable, and looking forward to meeting you in the Q&A. Thank you.